going to talk about limits. Now, limits is one of the most important topics in calculus, but once you get the hold of it, it's really, really easy. So, limits is like kind of one of my favorite areas in math because it's really simple. So, what are limits? This is going to be a really basic introductory video in which I'm going to tell you the basics of limits, and then later on, I'm thinking of making a more complex video with really, really tough questions that you get based on limits. Alright, so what basically is the meaning of a limit? Let me take an equation. F of x equals, say, x plus 4. Alright. So what does an equation actually mean? The equation is a mapping between f of x, which we also take as y, and x. So at any point of time, if I know my value of x, if I know my x is 3, I know that my y is 7. So it's basically a mapping between x and y. So I know x, I can get my value of y. I can map my x to my y. And then if I know my y, I can reverse map to x. So we can also make this in the form of a graph where when x is negative 4, y is 0, and when x is 0, y is 4. So we get a straight line like this. So then comes the concept of limit. Now, questions are of the form limit, LIM, x tending to 2, f of x. So what basically the meaning of this expression is that when my value of x is approaching 2, what is happening to f of x? So over here we have a really, really, really easy algebraic linear expression of x. So we can easily say, well, geez, when x goes to 2, obviously my y goes towards 6. So this is really, really easy, and it's totally like it's a straightforward plus expression, right? But let's see how this can get really complicated. Now let me take my f of x equals x squared minus 4 upon x minus 2. Now we all know that the numerator is of the form a squared minus b squared, which is equal to x plus 2 times x minus 2, and then we have our x minus 2 in the denominator over here. So now when I ask you limit f of x tending to 2, you may easily say that we cross these two out and we write 2 plus 2 equals 4. But this is the very, very crucial point of this, because you can only cancel out the numerator and the denominator when the denominator is not equal to 0. But when we see our value, when we see that our x is approaching 2, when the value of our x equals to 2, we get an x plus 2 times 0 upon a 0. And a 0 upon 0 form, 0 divided by 0 equals not defined. We have 7 or 8 indeterminate quantities in mathematics, and 0 by 0 is one of them. So we actually don't know what the value of 0 by 0 is. So when I say that when my value of x is 2, actually f of x has no value. There is no value of f of x because we have a 0 by 0. So this is where the concept of a limit becomes really, really useful, because what we are doing in the form of a limit is that we're saying that, alright, at x equals 2, we don't have any value of the expression. What happens when x approaches 2? So what does the value of my expression, what does the value of this fraction approach to when I get closer and closer and closer to 2? So what we can do in this is that we can make a graph. So when x is not equal to 2, our f of x simply equals x plus 2. And how does my graph of x plus 2 look like? When my x is negative 2, y is 0. When my x is 0, y equals 2. So this is my graph, right? And then here we have x equals 1. Here we have x equals 2. So when my value of x is 2, the value of this is indeterminate. So we make a hole in the graph. But now when we look at the graph, we know that when my x is going towards 2 from here, or my x is going towards 2 from here, when I'm approaching when I'm approaching the value of 2 for x in both directions, right? I'm going from here, what is my value approaching? my value is approaching 4, which is simply equals to x plus 2 when x equals 2, which you would normally do if my f of x were simply x plus 2. So what my meaning of my limit is that, alright, we understand that because we get a 0 by 0 at x equals 2, my value is not defined at that particular point, right? So if I go exactly, I jump onto this point at x equals 2 and see my graph, no value. My graph is not defined. But the basic meaning of a limit is that when I'm moving closer and closer and closer, I'm going to 1.99999, or I'm going from the other side and I'm like 2.00001. Then my denominator is defined because this is not 0. It's a really small number, and on the top it's a really small number. Because they're not 0, we can cancel them out, right? So we can cancel them out, and as my value of x is like 1.99999, really close to 2, so when we add 2, it becomes really close to 4. So the meaning of the limit of f of x when x approaches 2 is 4. So we're just basically saying that there's a kink in the graph, so we can't exactly know the value at that point, but we're moving close to that point in all directions, and we want to know what value the function assumes. So in this example, I've solved the limit using factorization, right? I've crossed the factors in the numerator and the denominator, then I've simply plugged in the value of 2 in x plus 2, and I get 4, and I get my answer, which is what my function approaches. So there are many different methods of solving limits. Some of them are like differentiating the numerator and denominator, then there's factorization, and there are a few other methods which I'll discuss in future videos, but basically you understand the fundamental concept of a limit. We just study where our function approaches when my x approaches a particular point. So it's basically a mapping between the function and x. So I simply ask myself, whenever I'm given a limit, I'm asking myself, when my x is approaching a particular value, where is my function going? It's a direct mapping between my function and x. So when x is approaching a particular point, where is my function going? Alright, if you like this video, please give me a thumbs up. I love it when you guys give me a thumbs up. Subscribe to my channel to get to know about new videos, like my Facebook page. And if you have any doubts or if you have any portions on which you'd like me to make a video, please post them in the comment section below. Thank you. I love you guys.